all our events recordings from our YouTube channel. If you subscribe, you will see different meetups and the diversity of topics in machine learning, data science, and artificial intelligence. And we are putting some workshops there. We'll get additional information in new topics. Yeah, just highly encourage you to join our YouTube channel. Also today, as I mentioned, highly encourage you to finish the program. When you finish the program, you may be able to eligible for our follow-up program that we are offering, Mentorship Bootcamp. So Mentorship Bootcamp we are offering, I will briefly introduce about it. I'll just share screen if hosts enable me. This free program, and we are offering another free program in Python in this month. If you're able to complete that programs, you will have a good enough prerequisite to join Mentorship Bootcamp. With these programs, our goal is to get you ready to the job market. And our programs are designed for the needs of industry at Silicon Valley specifically. But I tell you, there's thousands of companies here, and they are all looking for machine learning, science, data science, and artificial intelligence scientists. So it'd be good to get a traction, get yourself ready with our programs to able to qualify for jobs outside. Our goal is to get people ready for that. And those free programs will give you great understanding, and we encourage you to, after free programs, do projects yourself. But for the people, we are also offering projects and from real world. We are working with startups and we are working with universities. We take those projects and you'll be able to complete this project as our mentorship bootcamp. And we have mentors from top Silicon Valley companies and Stanford. And we have practice interviews and we have career coaching in there. We are actually going through your resume often, and you're getting also practice interview. We are telling you what you need, what you're missing. And we are also, there is also possibility to do internship with the companies actually we are affiliated with after the program. I just go to a brief outline of the program. So the mentorship bootcamp, it's in 7 weeks, and we have 3 modules: NLP, distributed machine learning, and deep learning modules. You will have 2 weeks project in each one, and you will do several projects. And after that, you will have practice interviews. In meantime, resume coaching, industry insights, and also we are connecting our students with the recruiters here in Bay Area and all US. So just give you that information, but I encourage you, because we get a lot of applications and we have really limited space, because this is, we assign 3-4 mentors to small group of students for each group. So we provide a lot of mentors and instructors, but we have a limited space for it. I encourage you to just do it well in this class and finish this class and others, and prepare for interviews that we make an interview to accept people in this, in that mentorship bootcamp. Just prepare yourself for this program. Hopefully you'll be able to qualify. And we also prioritize people who join this free programs and they finish. We prioritize these people first. So I hope you can make it. And I will finish that here, and I will also introduce you Dr. Ceran. He's a professor in Santa Clara University, and he's a adjunct professor in KAIST University in Korea. And he's also visiting scientist at Stanford University. He's been working on data last 20 years. He's one of the best people we can learn machine learning from. I hope you can take good benefits of learning from him. I just let him start. I hope you enjoy.
I'll be teaching this class for the next 5 weekends. And as Dr. Badai said, we are going to have TA support during the weekdays. And my friends are going to let you know when the TA is going to be available with you. I'm going to share some assignments so that you can go with the TA step by step on the assignments yourself. If you allow me one more second, I'm going to share the link for the material for this class with you. And before each class, I'm going to share the link with you so that you can download the material and then follow the class. Just one second, I'm going to give you the material. Okay, I just shared the link from the chat, so you can download the material. Again, from time to time, I'm going to share the link because there are so many messages in the chat, so my voice might be lost. So one thing I always remind before, so we have been doing this for a while. So one thing I remind everybody before we start any program online is that when you are following an online program, which so many of them are available, so much of material available, you don't have to go to any school or anywhere to learn about machine learning, so much material available. But last year, I just went through a number of attendees on a machine learning class, and everybody should know about it, right? A Stanford professor, Andrew. So his machine learning class, which is available for free at Coursera, at YouTube. I just went through the numbers, and then I wish I had access to my iPad so I could show you the graph. So the first week number of attendees or listeners, I just looked at the YouTube numbers. First couple of lectures is, hundred thousands. And then as we move forward, after 2-3 weeks later, the number of people who are actually going through the material is dropping to, to maybe, let's say, 30,000s. From hundreds, for example, 500,000 to 30,000, 20,000. So the thing what I notice is people start but they don't go through the material. So it makes a lot of sense if we go through the material until the end. So, and then once you're done with that material, you can start with another one. If you jump from one material to another, that's my observation. Students are not getting the much benefit that they could get from the classes. Okay, so this is just an introduction part. It's gonna be very quick. Then we'll start with supervised learning models very quickly. For this class, we're going to use Anaconda. So you can easily download Python from Anaconda distribution. So the link is there. And if you guys are interested in machine learning, you might have heard about Anaconda. And then again, from the material, just click on the link and then download the Jupyter notebook that we're going to be using for this class. The Python knowledge, there is an excellent material for free available at this link. Again, you can go through this Python data science handbook at your own pace slowly, which is going to give you a good overview of Python, which you can use for data science purposes. And it's an excellent source. And for this class, I'm mainly going to use the class notes and textbook and code examples from Andrew Muller's textbook, Introduction to Machine Learning with Python. It's a very easy to read book for beginners. There are so many nice books out there, but this is a book which is very good for the beginners. So I'll be using mostly his notes and then code from this textbook. So machine learning is all about capturing knowledge from the data. We are going to capture the patterns in the data. So much of data is available. There are different types of machine learning: supervised learning, unsupervised learning, reinforcement learning. So there are a couple of more types actually, but in the industry, mostly we are using supervised learning and a little bit of unsupervised learning. So in this class, we are going to focus mostly on supervised learning. What is supervised learning? So we have the data, and then we have the label for this data. For example, if we are talking about income level of people, and we gather data about people, right? Like age or number of years a person spent on education, his zip code, right? then each piece of this data, his age, his number of years he spent in education, or his zip code, will be the attributes or the features of your data set, right? And then what we are trying to estimate for each person is his income. In this case, the income will be the target variable. And when we have data set about individuals, which tells us age, education level, and zip code, in addition to his income, we call this data labeled data, because in this data, not only we know the features about each individual, but we also know the value of the label or target variable for this individual, each sample in the data set. So we are going to be using this label or target to train our model so that we can make estimations for individuals that we don't know their income. So that is supervised learning. So we are going to be using the target variable or the label when we train the model, right? This is supervised learning. When we sometimes there will be occasions where we have the data set, we have the features, but we don't have the target variable, right? But in that case, what we're going to do is without the labels, without any feedback, we are going to try our best to cluster, in this case, the individuals or the samples or the data set. We are going to put data points into groups because we don't know the label, right? We don't know the target variable for each data point. We can only put them into groups. We're going to try to find some hidden structure in the data set. In that case, we are going to be using unsupervised learning, right? So we are using unsupervised learning in the market to determine, say, market segments, right? So, for example, you are running a website, and then so this is one problem that I was talking with a platform owner. So they are receiving millions of visitors daily on their website, and some of these people are already subscribed to the website, so they know about these people, right? They know about their intentions, but millions of the visitors are not subscribed. They're just visitors, so they don't know their intentions. Are they out there just to read about reviews of the products? Or are they out there just to actually to buy something, right? So, or are they out there to maybe switch from one product to another? So there are different types of people coming to website with different intentions, right? So we don't have the labels for the people coming to the website. So he was looking for, is there any way we can differentiate those visitors and then, put them into clusters so that I know this type of visitor is actually trying to learn about a product because he wants to buy a new product, or this person is not happy with this product, but he's most likely going to switch to another product, right? So there are different types of visitors coming to website, but we don't know their types in advance. We need to cluster them based on their behavior on the website, for example. So this is unsupervised learning. Again, in this class, we are going to mostly focus on supervised learning. So as I said, we have the training data and the corresponding labels. We're going to feed this label and training data into the machine learning algorithm, and then we're going to train a model. This predictive model later on will receive new data that we don't know the labels of, and then we're going to make our predictions. This is the supervised learning. So what we do with supervised learning is from known data points, we are going to form a general model that is going to help us to make estimations on data points that we don't know the labels of. That is supervised learning. When we have supervised learning models, we are going to be using these models for two purposes, mainly. One is for classification, the other one is for regression. So we'll be using classification when our target variable or the labels take discrete values. So what is discrete? What does that mean? So I'm teaching a class to students, and I want to develop a model based on their performance or based on their attendance. I want to develop a model which is going to help me to estimate whether a person is going to pass or fail this class, right? Pass or fail, 1, 0, yes, no. When the target variable is discrete and it doesn't have to be binary. Binary means taking only two values, right? It can be categorical too, right? In that case, we are going to have a classification algorithm. But if we want to estimate or predict a target variable that is going to take continuous values, right? Continuous means the available values for a target variable is infinite. For example, instead of predicting whether a student is going to pass or fail a class, is there any way I can actually predict his grade, right? So out of 100, right? Is it going to be 60 or 61 or 62 or 65 or 95, right? So in that case, I will be training a model for regression, right? In this case, my target variable will be a continuous variable. Let me make this bigger. Okay, so classification, I'm going to classify my data points. In this case, on the screen, you have data points with two attributes, x1 and x2. On the left-hand side, I have certain data points, let's say negative ones. On the right-hand side, I have positive. So this is an example for data points that are linearly separable, right? A linear line is going to help me to separate these two groups of data points. So on the right-hand side, this time I have, again, data points with some feature, in this case, a single feature, x. Y is the label value. So like, this is the student, this is his grade, this is the person, this is his income, right? And then I'm trying to come up with a model, in this case, a regression model, that is going to help me to estimate or predict, let's say, the grade or the income of an individual when a new individual appears that I don't have any information about the value of his target variable. I don't know his income, or I don't know what his grade will be, right? So in that case, I'll be using this line, this regression line, to make that prediction. So this is regression model. So based on what data we have, they are going to form a model as general as possible. So we're going to come back to this model being as general as possible in more detail. So this is just an introduction. So we'll deal with these in more detail in a minute. So I said unsupervised models, unsupervised learning, they are trying to cluster or find some pattern in the data set without actually guided by any target variable, right? So here, these data points somehow are close to each other for some reason, right? So then I consider that, I infer that these data points are within the same cluster. They are similar based on some similarity metric. So, or these guys are similar. Another way to use unsupervised learning is we can use it to reduce the dimensionality. So when we have so many attributes, so many features of a data set, sometimes it might be helpful to reduce the dimensionality, let's say into 2 or 3, so that I can visualize the data set, or I can remove the noise from the data set, or I can compress the data set so that I can represent data set in a lower dimension, right? So in that case, again, we're gonna be using unsupervised learning. Again, this is just a very regular, ordinary machine learning workflow. We are gonna collect the data set, we are going to clean and transform the data set. We are going to separate a part of the data set for test purposes, which we're not gonna touch that test data set. And then we are going to train the model, test our model based on our test data set, and deploy the model. We are not gonna stop there. We'll continue gathering data set, and then we are going to go through this loop, depending on the context, frequently or with some certain frequency. It might be really frequently, or it might be every month or every year. We may need to update the model based on the new data set that we are collecting. Okay. So when we are representing our data sets for our code, which I'm going to show you a couple of examples in a minute. Just be patient, please. When we're representing our data sets, we are going to have, for our supervised learning models, we're going to have two main components. And by convention, we'll be using the capital letter capital X for our data set and the small letter y for our target variable. So this doesn't have to be this way. You can name anything. You can name this label or target. You can name this your data, whatever. But by convention, we are using capital X and small y. So this capital X will be our feature set for samples. So each row will be corresponding to a sample. So if your subject is a person, each row will be corresponding to a person. Right? or a product, right, or a sale. And as you see, each row has multiple columns. So each column will be corresponding to a feature. Okay? A feature is, in this case, for example, if the sample is an individual, a feature might be his age. So another feature, another column might be his level of education, right? Or his zip code. So some of these values will be numeric, continuous, some of them will be categorical, right? So they may take binary values, they may take values from multiple categories. So we are going to deal with numeric values and categorical values later on. Okay? So this is our X feature set. And Y will be the corresponding target value. This is the label or target. So for this one sample, this blue box, the corresponding label is 1.6. Later on, when we are going to shuffle the data set, okay, I mean, if you are doing things manually and when you are shuffling your data set, one mistake that sometimes I see students doing is they are shuffling data set, but they forget to shuffle together. They forget to shuffle the target variable. So the sample and its corresponding label should be moving together. So we will never lose this correspondence, okay? So this information here is very valuable for us. So this individual, whatever that is, this can be a product or individual, the target value is 1.6, and we are going to be using these target variables values to train our supervised model. Okay, so when we are developing our model, we are going to divide our data sets mainly into two groups. And later on, we'll see that we are actually going to be dividing into many different subgroups, but mainly into two groups. We're going to call them one group as training set, the other one as test set. Okay, so we'll be using training set for training the model. Once we train the model, and only after we train the model, we are going to use this test data set, and this will happen ideally only once. We are going to use our test data set to test how well our model is doing. Okay, I said ideally only once, use the test data set ideally only once. Then you might ask, how am I gonna know my model is doing, right, when I'm training my model? So for that purpose, actually, we're gonna actually divide our training data set into two further groups. So one group, I'll call it training set. The other group, I'll call it validation set. So I'm going to be using that validation set to see how well my model is trained. And then I'm going to use that validation set to set certain parameters of my model. Okay? And then we'll come to that again in our examples. So if this brief and maybe boring introduction is enough, so let's just look at some examples let's start from very basics on how we can load the data set using pandas. And sometimes we'll be using data sets that are already available at scikit-learn, some toy data sets, so how we can also upload these data sets and then how we can work with them. So I'm just going to, can I see this? Okay, so yeah, this is our first Jupyter notebook. As I said, I'll be using Jupyter notebook for this class. You can use other sources too. So I'm using Colab for when I'm teaching deep learning to students. But for machine learning and for introductory machine learning, I'm using Jupyter notebook. And you can easily write your code and then run your code and then see the results immediately on the screen on the same platform, actually. So it's very useful, very convenient. So I like using it. So for this exercise, we're going to learn about how we can load data sets from files. If your file has an extension of CSV, right? So for that, we'll be using pandas read_CSV function for that, right? So for that, we need to first import pandas. and I am going to load my data set from pandas using pandas read underscore CSV. So this is my data set, okay, my whole data set, all right? So this data set now includes both X, capital X, and Y, my feature set, as well as my, my target variable, right? So after you load, let's load the data set. Let's go step by step. And by the way, after I go through this, there is a small exercise, so I'm gonna pause a little bit, and then I'm gonna go through that exercise with you step by step. So this is for just for illustration, then we're gonna go through the exercise together. So now I'm loading my data sets. Again, I'm using pandas read CSV. There are different ways of loading data sets, so I'm just showing you how to load with pandas. Once we load our data set, the first thing, one of the first things actually we should do is check the first 5 data points and then how they look like, what are the column names, what kind of values these guys are taking, right? Just to see how our data set looks like. So for that, I'll be using head data. Now our data set is a data frame, right? Data set is a data frame, Panda data frame. So I'll be using head to see the first 5 data points in our data frame. So yeah, we have age, work class. So this is a survey data set. We have people at each row, individuals, and then we have age, work class, education, number of years in education. So these are the features. Some of the features are, as you see, numeric and continuous, and some of the features are categorical and discrete. So work class is taking discrete values. Education is taking discrete values, right? But age is taking continuous values. So later on, again, we are gonna deal with these categorical variables, because as of now, I cannot use this data set to train my, say, regression model. I have to turn, say, race, gender, relationship, occupation. I have to turn these features into numeric values, right? I have to encode them so that I can use them in my model. Okay. So another thing that I should do, as one of the first things I should do after I check how my data looks like, the first 5 data points, I should also see how many data points I really have, right? How many observations I have, and how many actually features I have. For that, I'll be checking, I'll be using shape, right? Data.shape. So this will give me number of observations and number of features, right? So number of observations, 32,561. I have 32,000 of observations, 32,000 rows, and I also have 14 columns, 14 features. Okay. So another thing that later on you might be using, again, in the examples in our next class or next class we'll be using, you might need to, store your column names, right? So that's another useful thing to look at. So you can simply, assign your column names. These are the column names: age, work class, education. These are the column names. You can assign them to another variable, and then later on you can use that variable for different purposes, to slice your data set, right? Or create transformers, right? For that, you might need your data columns. So that is another useful function to know. Data.columns method, actually, it's going to give you the list of the columns in your data set. Okay, now these are all part of the pre-processing. I'm thinking to give one lecture on pre-processing, actually, in more detail, how we can pre-process the data set. So another useful thing is, if your data points, some of your data points are, discrete, taking discrete values, right? So you might wonder how many, for example, let's look at our income. Income has actually 2 values. It's taking only 2 values, less than 50K or greater than 50K. So you don't see greater than 50K, but I know that there is another value for income, which is greater than 50K. So I might wonder how many of the samples, right, is less than 50K, and how many of them are greater than 50K, right? So for that, you might just count number of values, different values, unique values in your data set. So this data is my whole data set, my whole data frame. So I can have access to individual columns. I'm just going to focus on income. right? Income, this column. And then I'm just going to count number of different values in that column, value underscore counts. So this will give me in my data frame for my income feature, how many of each unique value I have for income feature. So I have 24,000 less than 50K and 7,800 for greater than 50K. Okay, so this, I'm just trying to understand how my data looks like. Okay, so I'm just exploring my data set. All right, so without running any machine learning algorithm, going through this exploration actually might help you a lot to understand what this data set is about. And it might give you some ideas, right? Some insight about this. For example, about this data set, again, let's focus on our income because this is basically our target variable. Later on, I'm gonna separate income from my data set and assign income to Y. So I'm also just curious, right? How this income is distributed across different ages, because I have an age feature here. Where is that? Here, right? I'm just curious, right? So if out of all these people who have less than 50K, how are their ages distributed? And out of people who have income more than 50K, how are their ages are distributed? So I just want to see that, okay? So for that, what we can do is we can group by our data based on, in this case, income. When I say data.group by, what this is gonna do is this is gonna separate this data set into two groups. One group will be those who have income less than 50K. The other group will be those who have income greater than 50K. Right? So then what I can do is, for those who have less than 50K, I can take a histogram of the age for that group, right? So once I can group my data sets, okay, here, I grouped my data set by income. Right? So then next thing is I'm gonna focus on the age attribute of the first group, let's say, the first group, which is less than 50K, and then I'm gonna take the histogram of the ages of this first group. So histogram is going to divide my data set into bins. And then for each bin, I'm just going to observe the frequency of that bin, right? So for example, for those who have great income less than 50K, right, I see that most of those guys have age around 20, right? And then as age advances from 20 to 80, as you see, the frequency is dropping. That means those who have income less than 50K, as they get older, right, number of people who have income less than 50K is also decreasing. That's what it says. So most of the people who have income less than 50K are actually, their ages are focused around between 20 and let's say 40. Okay, that's what it says, the data says. So now let's look at the other group, which is income greater than 50K. Again, I'm looking at their age and then histogram of their age. And it shows a nice Gaussian distribution, actually, right? Almost like normally distributed, a normal distribution, right? Normal distribution is a symmetric distribution centered around the mean, right? In this case, I mean, most of the people actually who have less than, greater than 50K, their age is centered around 42, right? So I have really small number of people whose age is around 20 and have income greater than 50K. And I have people, again, small number of people whose age is greater than 60 and also have an income greater than 50K. Most likely these guys are retired. These guys are very young, right, to make that much income. And these people are working, right? They have the job, they're working, and they're making greater than 50K, right? So again, without even looking at anything, I had a good idea about my data set. So without running any algorithm, if you tell me the age of that person, I might make a good guess about his income actually, right? If you tell me this person is 20 years old, most likely his income is less than 50K. If you tell me someone around 45 years old, well, it's almost like equally, right? Equal like this person might have less than or greater than 50K, right? Okay, so Next thing is, once I go through my data, and then by the way, there are so many other things we can do here. As I said, I'm going to have a separate session on pre-processing. Next thing is, I'm just going to split my data into two groups, my feature set and my target variable. X will be my feature set, Y will be my target variable. What I'm going to do is, again, I'm going to use my data frame. This time, I'm just going to drop income from my data. So I still keep my data. My data is still here with 14 features. What I'm going to do is, I'm just going to drop income from my data, and then the remaining 13 features, I'm going to assign them to X. Okay, here. X is all my data features except income. And I'm just going to assign income to Y. So Y is going to be income. X will be all features excluding the target variable. So if you like, you can just check how your X looks like. As you see, income is disappearing now. So this is my feature set. And this is my target variable Y. Okay, this is the first 5 data points. All right. Next, I'm just going to split my data set as I try to show you here, right? I'm sorry, this one, right? I'm just going to split my data set into 2 pieces, training and test data set. Now, you can split your data sets, but when you're splitting the data set into 2 pieces, you have to do this randomly, right? So you need to pick random samples from your data set and then assign them to training, and then the rest will be assigned to the test data set, right? So you can do this, you can write the code for this manually, which is not very difficult. But we are using in this class mostly scikit-learn, and scikit-learn already provides us with a class that will help us to make this train test split, right? So what we're going to do is we are going to import train test split class from scikit-learn's model selection library. And I'll be using train test splits to split my data sets X and Y exactly from the same locations into 2 pieces. So by default, this split is going to be 25% to 75%. So 75% will be my training data set, 25% will be my test data set. Okay, so one, I mean, just for a note here, when you are listing train test and train test, make sure that you list X train and X test, and then Y train and Y test, otherwise it's giving error. So this order might differ from for some other libraries, but for train test split, it's X train, X test, Y train, and Y test. Okay, so I split my data set into 2 pieces. Now I can look at the first 5 observations. As you see, the first 5 observations indices are very different. Look at the first 5 observations indices. I'm starting from my first data point, which is 0. Index is 0. Index is 0. Then index is 1. Then index. My data is, it has some order here, right? 0, 1, 2, 3, the indices. Because when I split my data set, I'm splitting it randomly. As you see, the indices are totally random now. So the first data point in my test, the train data set is, the index is 24,900. Okay, so this is my train data set because it is 75% of the total data set, total number of data points. I have now 24,000 data points in my train data set. All right. So up to this point, we learned how to upload data and take a slice of that data set. And then we learned how to split this data set into train and test data points. So let's go through this small exercise here, and then we'll do the same things in a different data set. Okay, so let's do this one. I also gave you the data set for this exercise, Boston house prices data set. So I'll use that data set. Okay, so we are going to load Boston house prices. So in my case, my data is in this folder, data folder, as you see, data folder. So, but in your case, your data is in the same folder with your file. So just keep this in mind. If your data is in another folder, you have to give the path to your data set. Okay, so let's start. We are going to import, and then you can also do the exercise with me step by step. We are going to import pandas first, And then I'm just going to use an abbreviation for that. You don't have to do this, but it's gonna make your job easier. So I'm gonna be using pandas, and I know that I will be splitting my data set into train and test. So I'm just going to import from scikit-learn, right? And model selection library, I will be importing my train test split class. Okay, so these are the two libraries that I will be importing. If you want to add another cell which you can type your code, you're just going to click on this one. Okay, so this is my first, and then if you want to run this for Mac, you can use Shift and return, okay, or you can select this cell and then click on this one. Okay. So I'll be using Shift and return. Okay. And two. This is just 1 second. We don't say import, we say from, so I just typed it wrong. So you should say from scikit-learn model selection. So, okay, so I imported the my pandas and train test split. Next thing is I'm going to load my data sets. So let's call it data. You can call it anything, your data, my data, data one, data two. And as I said, I'm just going to be using pandas for that. For pandas, I'll be using PD abbreviation, and then I will read my data set, okay? So where is my data set located? I know that my data set is here in this folder, data. So yours, you don't need it, or wherever it is located, you can just run it. And then the name of my data set is Boston house prices, okay, .csv. Okay. All right. Now it says can we check how many data points we have, how many columns we have, right? So can we just print that here? So I think we can do it. So let's first load this data set. Okay, our data set is loaded. So now let's just use print to print this information. So I'm just going to print. So let's print number of samples. Okay. Now I'm just going to use a placeholder here, and this placeholder will hold the place for my for number of samples variable, which will come in a moment. Okay, so this is number of samples, and then I will also have number of features. So let's hold this place here. Okay, that's enough. Number of samples is this, number of features is this. I'll be using string formatting. Okay, so, and then for number of samples, I am going to take my data. Remember, I can print the shape of my data, right here. Data shape is going to give me this tuple, right? The first one corresponds to number of observations. The second one corresponds to number of features. So that's what I'm going to do. By the way, let me show you. If you say data.shape, right? It's going to give you a number of observations and number of features. If you say data.shape 0, right? So it's going to give you only number of observations, because data.shape is a tuple. Sorry. It's a tuple with two elements. The first one has the index of 0. The other one has the index of 1. So if I say data shape 1, then it's going to be 14, right? So data.shape 0. This one, data.shape 0 will correspond to number of samples, right? And then 1 will correspond to number of features. So let's make this look nicely. Okay, so my number of samples is 506, and my number of features is 14. Okay, so if you like, you can print number of print the columns. So let's say columns. Okay, and then remember, I can print the columns, right? How can I list the column names? Remember, so this is my data, and then I have a method. Data is a data frame as of now, and data frame comes with its own methods, its own functions, right? So one of those methods is columns. What is this? This lists the names of the columns. So if you wonder what are these columns, here are the columns. These are the names of the columns in my data set. By the way, you can also make the first 5 observations. These are the names of the columns, and these are my observations. So most likely this guy here is a categorical variable, and the others look like continuous variables. Okay. What else are they asking? So this is a regression data set. Regression data set means the target variable is continuous, okay? And MEDV, median value of the house price, is the target variable, okay? How many features are there? How many samples? We already answered that question. So let's split the data sets. So let's first split into X and Y. So again, this is my data. I'm just going to drop median house price, right? The name is MEDV. Right? I just drop it. When you drop, you need to also say, are you dropping a column or are you dropping a row, right? I'm dropping a column, so I will say axis is 1. So that means I'm dropping a column, right? And then Y is, again, my data. And this time, you can simply say data dots. Okay, so this is my X and Y. Okay, so say here Y dots. And you see, these are the first 5 observations from my median house price. Okay, next thing is, let's now split my data set into train and test data set. So X train. Remember which one comes next, right? X test, right? And Y train, then Y test. Okay, so I already loaded train test splits, so that's what I'm going to use. Train test splits. Now I'm going to be splitting my data set X and Y together, okay? X and Y, all right? So after the split, if you want to see what is your train data sets dimensions, right? Number of features and rows. So I can say X train dot shape, same thing. This time 75% of my data set will be included in the train data set. Okay. One last thing it says, asks me to do, after you split your data set, can you plot median house price versus any of the features using the plot method of the data frame using scatter? So basically what I'm going to do is I'm going to make a scatter plot of my data set for median house price and one of the features that I select. Okay, so let's do it. By the way, this data frame comes with methods. I said one of the methods is plot method. So you can do this again in various ways, but this is a very simple way to do it. So this is my data set. Remember my original data set. It's a data frame. It comes with this method, which is called plot. So this plot will help me to plot graphs, right? So what am I gonna do is I'm going to create a scatter plot of median house price and say number of rooms. So what is your expectation here? When number of rooms increases, I expect median house price also increase, right? Okay, number of rooms. I'm going to plot this versus median house price. And so this can be any plot. So the kind of the plot that I'm looking for is scatter plot, right? So let's see. So this is room number, this is median house price. As we expected, as room number is increasing, median house price is increasing. There's almost a linear relationship, right? So again, as part of pre-processing, we're gonna deal with this frequently. We are going to create scatter plots of pairs of feature and the target variable to see what kind of relationship target variable and the feature has. If it is linear, if not, should we transform our feature to make it look more linear or more Gaussian or more normally distributed? So all that will be part of the pre-processing. Okay, so let me give like stop here for 5 minutes, and then I will continue with the next example, and then we'll continue with the with supervised learning. Just 5 minutes break, okay? I said we can load data set using pandas. We can also load data set using from scikit-learn's data sets. So from time to time, for learning purposes, we might use these data sets, these toy data sets. So in this case, I'm just going to load some digits, handwritten digits from scikit-learn's data sets. So these digits are similar to or transformed images from MNIST dataset, which is a very popular dataset for image recognition. And for loading datasets from scikit-learn, we are going to import load digits, load underscore digits from scikit-learn. Okay, so in this case, I mean, the dataset is load digits. If it is another dataset that we are loading, the name will change. So from scikit-learn datasets, we are loading digits dataset. Okay, later on, I think there is another dataset, load cancer. We're gonna be using that dataset as well in our exercises. Okay, so I'll be dealing with arrays in this case. So I'm importing NumPy, and for NumPy, I'll be using NP as the abbreviation. And to load the digits, to load the datasets, load digits, you can simply call this function load digits. So it will load the dataset to your screen, but I'm going to assign this dataset to a variable, and then I call it digits. So digits is now it's now coming with 5 things actually. So it's a dictionary, it's a Python dictionary, and it has keys and values. So the keywords are data, target names, images, and description in this case. So I have the data and target already available. So I don't need to split my data into X and Y. It is already given as a split from scikit-learn. Okay. So I'm giving this part of the lecture in this way because when we are using scikit-learn datasets, sometimes students are confused. So that's why I'm just telling in advance that data is already coming in this format. If you want to see what this data set is about, you can take digits. Remember, digits is holding the dictionary, and description is the name of the keyword. This is this description about the data set, and this is the value for description. So it just gives some information about what this data set is about. Okay, so you can have access to data. So digits, remember, is the dictionary. Data is the data set in the value. Data is the name of the keyword, and then digits.data is the value corresponding to data keyword, which is the data set. And this is the shape of that data set. So we have 1,790 observations with 64 features, and target variable is 1,797. So what is this target and what is this data? How do they look like? If you want to see how they look like, so you can simply print your target variable. As you see, target is just numbers from 0 to 9 actually, 0, 1, 2. These are digits, 9 digits. Okay, so that means we have a categorical variable in the target, right? Our label or target variable is a categorical variable with 9 and 10 different categories actually, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you want to see how many of each of these category values in your target variable, in other words, how many each of these unique values, how many samples correspond to each of these unique values, you can simply make bin count. Okay, so you're actually dividing your data set into bins, and then you are counting how many for each bin. So again, bin count is a method coming from with NP. NP is NumPy. We already imported it, right? That's why we imported it actually. So I can bin count my target variable, which is coming with my digits dictionary. So in this case, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 categories, and these are the numbers of samples for each category. In other words, I have 178 zeros and 182 ones. Okay, and I can take only one sample from my data set. If I do data 0, this is only one sample. This is the first sample in my data set, and I have 64 features for this first sample. All right. I know that this data set is numbers. So what I'm going to do is I'm going to put this my feature set into a matrix. So I'm going to make it look like a matrix. Okay. So again, remember, this is my first sample from my data set with 64 features. I'm going to turn the 64 features into 8 by 8 matrix. So what I'm going to do is first I'm going to choose my first sample, which is 64 features, and then I'm going to reshape it by 8 by 8. So reshape 8 by 8 will put this 64 features into 8 by 8 matrix. And then I'm just checking whether I did it correctly or not. So looking at checking the shape of this reshaped first sample, which is 8 by 8. Why did I do that? Because I'm going to use this to, in this case, just to plot, so to see how it looks like. Okay. So for plotting, I mean, there are different, tools available for plotting, but we'll be using Matplotlib, .pyplots, and PLT. Again, by convention, in most textbooks, you will see this. We are using PLT for abbreviation for Matplotlib. So what we're going to do is we are going to just plot my first digit and see how it looks like. When I'm plotting this, okay, when I'm plotting this, I am preferring to plot it in tones of gray. Actually, my data set as of now is composed of numbers, each number corresponding to a pixel, and each pixel is taking numbers from 0 to 255. So, but in this case, the data set is transformed, so it's not exactly 0 to 255. I know that, so it is transformed to make it look more simpler. But depending on the value of the pixel, I will be assigning a gray tone so that I can plot the image, right? So in this case, my image is, as you see, a 0. It's not a very clear 0, but it's a 0, right? So, okay, if you like, you can plot it in a different color. So that's why I put it here. This is the color map, okay? So I used grays and the blues. So the second one is in blue tone. Okay. The corresponding target value for this first sample is 0. As you said, this is my first sample, and this is the target variable. So this is the label for this first sample. So I know from my data set that this first sample is 0. Okay. Well, if you like, you can create subplots, right? Subplots, in this case, I only have a single plot. If you like, you can divide a single figure into subplots, and then you can put more number of figures, plots in the same figure. So what I'm going to do is, this is one single figure, but on this figure, I'm going to have how many? 16 numbers listed. So for that, I'll be running a for loop. right? So my for loop is going to take one sample. This is the first sample, this is the second sample, this is the third sample, and I'm also showing their corresponding labels on top of the figures, okay? All right, so this is my data set. Next thing is I'm just going to split my data set as I did before into two pieces, X-train and X-test. Again, actually two main pieces, train and test data set. Again, remember digits data is X, digits target is Y. So there is one additional thing you see here, which we didn't have before, test underscore size. Before we didn't use it because we used the default value. The default value for splitting data into two pieces, train test split is 25-75 split, okay? If you like, you can change this ratio. So this is the parameter to make that change. Again, your test size, in this case, 0.25. If you like, you can make this 0.10, right? So in this case, 90% of your data will be trained, 10% will be test. So let's turn it back to 25. And I have another parameter here, random state 1. So this is when you are training a model and when you want to replicate your experiments, or when you want some other person run your code and get the same results. So you need to fix the random seed, right? So what is random seed? Remember, when we are splitting data into train and test data sets, we are doing this randomly. We are sampling, taking random samples from our data set and assigning them into train and test groups, right? Randomly. So when we are making this random samples, that randomness is coming from a sequence of random numbers that is generated by the computer. So by setting, so each seed number, in this case random state, corresponds to a certain sequence of random numbers. So if I set the random state to 1, I will have a certain sequence of random numbers, and that sequence will be fixed. If I change this to random state 2, I will have another sequence of random numbers, and every time I set random state equals 2, I will have the same sequence of random numbers. So this way we can replicate the experiments, or we can replicate, get the same results for the same model. If you don't set your random state to 1, in this case, the data set, every time you run this, your train and test data set will be different. Because every time you run this without setting random state equals 1, a different random sequence of random numbers will be used to split your data set. Okay. As you see, the same things, you can check the shape of your train and test data sets. Let's do the same exercise. Same things. This time, let's load the iris data set, which is another toy data sets that we are using in our examples. So we'll do the same thing for this time, loading the iris data set. Let's do it. So I'm just going to load this from scikit-learn. Okay, so I will be importing, this time loading my iris data set. Okay, earlier it was digits data. Iris is the name of the data set. Okay, and then I'm going to be splitting my data set. So I'll be splitting my data set. This is coming from model selection port. Okay, so these are the two imports that I need. So next, let's import the data set. It's very simple. I'm just going to assign the name iris. You can use any name, but this part has to be the same, load iris. Right? I'm calling this function to load my data set. Again, remember, iris is a dictionary now. So the easiest way to assign X and Y, you can do this, is X and Y will be actually iris data and iris target. Okay, So this is X is my data, Y is my target, because iris is already coming with data and target. Okay. All right, now if you like, you can simply print the size of your data set. So set size is this, okay? And your number of features, let's use be consistent, this, right? Let's also this time, because I know that target variable for iris dataset is a categorical dataset, number of classes, how many classes, different classes do we have? So let's also use it, okay? These are the placeholders, let's be consistent, okay? All right, dot, I'm using string formatting. So the first one, dataset size, remember dataset size, X dot shape, right? Is gonna return a tuple. Tuple has two components. First component is number of observations. Second component is number of columns, right? Or features. Okay, X shape, this is data set size. And then X dot shape. The second one will be number of features. The third one will be interesting, number of classes. I need to find unique number of values, right? In my categorical variable, which is Y. Unique number of values. So for that, I'll be using numpy unique. So then I need to import numpy, right? Yes, np. Let's run this one more time. Did I make him? Okay. All right, so let's find the unique number of values in my target variable. Okay, for that, I'm just going to find the length. So let me write this separately. So I'm just going to list the unique elements of my target variable. Okay, unique. You see, my target variable has 3 unique numbers, 0, 1, 2. I mean, oh, it's a numpy array, so it doesn't have a head, so it's not a data frame anymore. Okay, 1, 2. So as you see, my target variable, the first 10 elements of my target variable are all zeros. So I don't know, how about 110 and 120. So between 110 and 120, I have all twos. Basically, my data is sorted out based on my target values, target variables values, right? First zeros, then ones, then twos, which is dangerous, by the way. Okay, so I have so many of zeros, so many of ones, and so many of twos in my data set in terms of target variable. So I'm just curious how many different target values target variable is taking. So that's why I'm checking this. Unique Y is giving, it takes 0, 1, and 2. These are the 3 different values your target variable can take. Now, I would like to print number of classes. So for that, I'm just going to take the length of this, right? This is a list. This is an array, actually. I'm just going to check the length of this array, which is 3. So that's what I'm going to write here. Length of. Okay. Okay. I think it's going to work. Yeah. So my data set has 150 observations. There are 4 features, and there are 3 classes. All right. Okay, now it's time to split the data set, right? X train, Y, let's call it X train, X test, Y train, Y test. Okay, equals train test splits. all right? And I have my X and Y, okay? You can, again, include these test size, random state, if you like. You can even say, instead of test size, you can say train size, which is not gonna make any difference. Whatever your test size, train size will be 1 minus that number, right? By the way, this number should be between 0 and 1. It's the ratio. Okay, so we have the X train and X test. Okay. Now, if you like, we can make a scatter plot. So let's do it. For that, we need to import matplotlib. So import plots, okay, as PLT. So this is my plot library, right? I imported this, and then I'm just going to plot PLT. So remember earlier we used plot method of a data frame. So let me go all the way up here, right? We used plot method of data frame. What is data frame? Data frame is our here data. Data frame is like a, think of it as an Excel table, but it also comes with certain functionalities. So this data is like an Excel table with observations and columns, but it also comes with some functionalities. What kind of functionalities? For example, I can see what is the shape of this data set. I can list the number of columns. I can see the first 5 observations. I can drop a certain column, and I can also make plots from this frame. So these are all functionalities of this data frame. Okay, now we're going to learn about how we can make scatter plot using a plotting library, matplotlib. Okay, so we are using a different tool now. So this is a plot, and then it is a scatter plot. Okay, and I'm just curious, right? How one feature versus another feature, how they look like, okay? Whether those features are correlated or not. For example, if you go back to your house here, right? So this is your data. Remember, this is our house data set. This is the target variable. You could wonder if age of house and let's say room numbers, how are they related? For example, old houses, do they have more number of rooms or less number of rooms? If you're just curious about this, right, you can have a scatter plot of 2 features, how they are correlated. Okay, for example, tax versus, what is that? Crime rate. So for low crime rate places, how is the tax numbers changing, right? So I would expect that low crime rate places will have high tax because those places will be houses with, higher prices, than high tax numbers will be appearing, right? So there should be some correlation between crime and tax. Okay, so I'm just gonna check if there is somehow correlation between 2 features of my trained data set. So for that, I'm gonna pick the first feature. So my trained data set is a NumPy array. So this is the entire column, the first column. This is the entire observations for the first column. Entire observations means so I have 112 observations. So I'm taking the entire set of 112 observations for the first feature. So I'll do the same thing for the other feature. Okay. Again, the entire column, the first feature. So this is going to be a scatter plot. But on top of that, I'm going to do something more. So if you just do this, yeah, this is one feature. This is another feature. And then what you see is these points are your target variables. Okay, these points are, so this is class 0, this is class 1, this is class 2. So 0, 1, 2. So, but right now, I don't know which data point belongs to which class, right? I don't know that. I cannot see that. This figure only shows me a scatter plot of one feature versus another, like room number versus age of the house, right? So this is one feature in my iris data set. This is another feature, and these points are my target variables, right? These are the categories 0, 1, 2. Remember the categories here? These categories 0, 1, 2, right? So I can add some extra information on this plot. What I'm gonna do is I'm just going to use my color map, okay? And then I'm just going to use my trained data set, okay, for my color map. So what's gonna happen is these data points now will take different colors. So in this case, we'll take one of 3 different colors, depending on the value of the trained data set, okay? So let's see. As you see, now I have 3 different colors, each color corresponding to a different class, because I know that there are 3 classes, right? And now this plot is more helpful, right? So I not only see how these 2 features with respect to each other, right, are changing, but also I see, when I see those 2 features, how the observations are clustered, right? So I have one cluster here, I have another cluster here, and I have a third cluster here. Okay, now I can do something more on top of this, right? What I can do is I don't see. I only can see 2 features because this is a 2-dimensional figure, right? So what I can do is I can add one extra piece of information to this graph. Okay, so let's see if I can do it. So I'm gonna include one more information about the third feature, right? And that information is going to be the following. Depending on the value of the third feature, right now I have only 2 features in this graph. Depending on the value of the third feature, these data points will look like big or small. If the third feature's value is big, this data point will be a big circle. If it's small, it's gonna be a small feature. So the color will tell me which class it belongs to, and the size of the circle will tell you what is the size for the third feature for this data points. Okay, so I'm adding some extra information here. So let's see. For that, I'll be using size, and this will be 100 times. So I'm just amplifying the size. Hopefully this is gonna work. So I'm just trying this one here, so I hope it's gonna work. Yeah. So let's make this 10. Maybe it's too big. Yeah, it's much better now. So as you see, I added a third component to my figure. So in addition to X1 and X2, the first 2 features, I'm also showing the third feature in terms of the size of the circles. So if the circles are big, I know that the third feature for these guys are bigger than the third feature for these guys. So not only, so I know that the purple group somehow are taking small values for the third feature. So this index 2 is corresponding to third feature, 0, 1, 2. So I know that the green ones are taking bigger values than the purple, but smaller values than the yellow group for the third feature. So this is also some additional information about the graph. Okay, so I'm going to start with the second part of the lecture now. Okay. Again, I couldn't somehow connect my iPad. Normally, I'm writing equations or taking notes on the PDF file as I'm teaching, but anyway, so let's go with whatever is available. Okay, so let's begin with supervised learning. I may not finish this today, because I'm planning to stop in 10 minutes. I'll continue with this one. So we are really getting started to real stuff now, okay? So we know what supervised learning is. So we have some idea. With supervised learning, we have the feature set and also the target variable, right? The label, actually. So that target value or label value will guide us when we are training the model. The simplest algorithm that we begin with for machine learning classes is k nearest neighbor. Okay, k nearest neighbor. I'm going to talk about what k refers to. So what happens here is when I have a trained data set, in this case, this is a classification problem. On the screen, you see a toy data set plotted. I have a classification problem. I have blue class and red class. So the data points you see with color are my training data points. Why training data points? Because I know their classes. So these guys, I know that they are blue. These guys, I know that they are red. I also have 3 data points, which I don't know their classes. So that is my goal, right? I'm gonna train a model which is going to help me to predict the classes for these 3 data points. So nearest neighbor is a very simple. It's the idea is very simple, but for large data sets, it's not very feasible. It's a very simple algorithm. So what happens is, when you train the model, training the model is very simple. You just memorize the data set. Okay, training is just take the trained data set into memory. When it comes to prediction, okay, what happens is if you have these 3 data points, when it comes to prediction, what you're gonna do is, for example, for this data point, I'm going to measure the distance between this data point and all other data points in my training data set. Okay, and I'm gonna pick the closest one, okay, and then I'm gonna predict that this guy here that I don't know his color, this guy actually belongs to, in this case, blue, because blue is the closest one. Now, k nearest neighbor, in this case, k is 1. I am only checking his nearest 1 neighbor, k is 1. If it was 2, then I'll be checking nearest k 2 neighbors. One thing, please keep in mind for k nearest neighbor, k, we prefer taking odd numbers because, for example, focus on this guy, the nearest neighbors are this, let's say this, and this. So how we're gonna predict which class this data point belongs to? 2 blue, 1 red, you're gonna take the majority votes, right? So for that reason, we are using k odd numbers for k, okay. So we are going to, as you see, we are going to predict the classes for these data points that we don't know their class of as of now, as the class of the nearest neighbor. Again, training is very simple, just memorize the data points. Prediction, you're gonna calculate distance. And how do you calculate distance? There are different metrics to do that. So you can take the absolute value of the difference. You can take the square root of squared of the summation of square of the difference between the features of the data points. This is called, this is another distance metric, Manhattan distance metric, right? So different distance metrics you can actually use. Okay, so going back to our train and test data set, we have a train, we have a test data set. We already split our data into 2 pieces. Okay, how do we do this with scikit-learn? I just showed you how to do that, right? This part, we know that, right? We can split our data set into train and test. All right, how do we train a model using scikit-learn? Okay, that is the next thing, which we also have some exercises about that. So for that, I'm going to import from neighbors library. Scikit-learn has neighbors library. I'm going to import kneighbors classifier class. Okay, kneighbors classifier. Okay, you can also have kneighbors regressor. Okay, this is kneighbors classifier. All right, so I'm going to take this class and I am going to instantiate this class for a certain number of neighbors. In this case, number of neighbors is 1. That's what I did here. number of neighbors is 1. Now, n underscore neighbors, this is the hyperparameter of the model. Hyperparameter of the model. A big part of training the models is tuning up hyperparameters. What does that mean? For this model, what number should I use for number of neighbors? 1 or 3 or 5 or 7, so that my classifier is gonna be the best I can get. Okay, that is hyperparameter tuning. So I instantiate my k-neighbor classifier. KNN is the name of that instance. You can name this anything. My KNN, your KNN, KNN1, KNN2. Okay, this is the instant name of the instant object for this KNN classifier for this hyperparameter value. All right. Next, the moment you instantiate this object, the estimators at scikit-learn and other libraries too, the estimator for scikit-learn comes with 3 main methods. Okay, fit, score, predict. So for most of the estimators, I mean for all estimators, we're gonna have fit, score, and predict, these 3 methods. So what is fit? Fit is the method that is going to help you to train the model. So knn.fit. So for fitting the model, for training the model, I'll be using my train dataset, xtrain and ytrain. So for k-neighbors classifier, fit simply takes the train dataset into memory. So what does that mean? I am going to only memorize, this is the data point, and this is his color. This is the data point, and this is, when I say this is the data point, means this is his X1, and this is his X2 feature value, and it is a blue data point. Okay, I memorize the data point. That is what k-neighbors classifiers training part does. Okay. Once you fit your model, okay, the next thing is you can test your model on your test dataset. So that is what's happening here, knn.score. But when you are testing your model, you'll be using the test dataset. Okay, so knn.score, x-test, y-test is going to return a score value. We call it, in this case, accuracy. What is that score? In this case, let's say I have 3 data points in my test dataset. This guy is blue, this guy is blue, this guy is blue. All 3 are blue in reality, okay? Their ground truth, true label values are blue. I know that. That is what supervised learning is about. I know the label values. I only test how well my model is doing by comparing the predictions my model is making with the true label values that I have, okay? So I now run my prediction. My prediction says this is blue, and this is red. In reality, the true label values were blue, blue, and blue, but my predictions are blue, red, blue. So what is my accuracy? I correctly estimated 2 out of 3. My accuracy is 2 out of 3.66, right? So that is what actually this part does. knn.score will return accuracy. By the way, we're gonna talk a lot about this accuracy, different types of metrics when the time comes. Okay. Not only that, you can also run predict method. What is predict method? So let's say you trained your model, you tested your model. Now it is time to deploy the model. So now you are happy with your model and you deployed, a new data point arrived. A new data point arrived and just landed here. So let's say there is a new data point here, okay? So can we write here? Okay, anyways, a new data point arrives here. Now I would like to predict, okay, what is the class for this data point? Is it blue or red? So that predict method will return the predicted, estimated, the predicted class for this new data point. Okay, that is the predict method. Okay. If you have more number of neighbors, the predictions will change. Look, this is red, this is blue, and this is blue when you are using k equals 1. K neighbors when you are using the nearest one neighbor to make your predictions. Then you take into account 3 neighbors. Look, it is red, blue, and blue. Now I'm taking into account 3 neighbors. This guy, it was predicted as red. When I incorporate 3 neighbors, it is now predicted as blue. This guy was predicted as blue. When I take into account 3 neighbors, it is now red. So that's why hyperparameter tuning is very important. Your hyperparameter tuner, your hyperparameter value is going to change your the accuracy, how well your method is doing, right? It's going to change the accuracy of your estimator. Okay, so let me stop here. I'm going to continue from this point on next time. Hopefully next time will be a little bit faster. And we will also let you guys know when the TA session will be, so you'll have some exercises to do with one of our TAs. Okay, thank you very much for listening for 2 hours. And I hope to see you guys next week, the same time. Thank you, bye.